Hi, I am Mahadev Dayal. Welcome to my YouTube channel Civil Tech. Today I will discuss about bearing capacity of soil. How to calculate the bearing capacity as per IS code. In this video we will learn what is bearing capacity and formula for calculation of bearing capacity as per IS code and a workout example of bearing capacity calculation as per IS 6403. Now, what is bearing capacity? It is the load carrying capacity of the soil. Okay, this is actually the ultimate bearing capacity. Now, what is safe bearing capacity? The maximum intensity of loading that the foundation will safely carry without the risk of shear failure of soil, irrespective of any settlement that may occur. Basically, it is bearing capacity after applying the factor of safety. Factor of safety considering it may be 3 or 2.5. Okay. Now, what is the formula for the calculation of bearing capacity as per IS 6403? Now, the soils with cohesion and angle of shearing resistance and the ultimate bearing capacity of the soil in case of general shear failure, that is equal to CNC. Okay. Now there are two types of failure. One is general shear failure and another is local shear failure. In another video, I will discuss about what is general shear failure and what is local shear failure. Okay. Now, in general shear failure point of view, the ultimate bearing capacity is equal to QB is equal to CNC plus Q into NQ minus 1 plus half B gamma N gamma. In the point of view of general shear failure, this is the formula for calculation of the ultimate bearing capacity. Okay. Now, what are the these factors? Now I will discuss. Now, NC, NQ, and N gamma, the bearing capacity factors. Okay. This table is also from IS 6403 table 1, and according to the values of phi, NC, NQ, and N gamma are varies. Okay. When the phi is equal to 0, that is equal to 5.14 for NC, and NQ is equal to 1, and N gamma is equal to 0. Okay. Now next is safe factors. This table is 2 of IS 6403, and shape of foundation. This shape factor is depends on the shape of foundation. Continuous tree footing के लिए SC is equal to 1.0, SQ is equal to 1.0, S gamma is equal to 1. Rectangular footing, this is equal to this, and square footing 1.3, 1.2, and 0.8. Circular footing 1.3, 1.2, and 0.6. Now this is depth factors. Clause number 5.1.2.2 of IS 6403. Okay. This is inclination factor. What is inclination factor? It is actually the angle of applied load to the particle. Okay. Now a worked out example. This is an example considering the data, and we will calculate the ultimate bearing capacity as well as the safe bearing capacity of IS 6403. Considering the depth of foundation below ground level, df is equal to 1.3 meter. Width of the foundation b is equal to 3.0 meter. So the ratio of df by b is equal to 0.43. Hence the foundation is shallow foundation. Okay, as per clause 6403 of 2.2.5. The length of the foundation is 3 meter. So width of the foundation is also 3 meter. That means it is a square foundation. And inclination factor, inclination of the load to the particle is equal to 0 degree. Means the load is applied on the footing is perpendicularly. Okay. Now soil layer data. Angle of shearing resistance phi is equal to 0. Cohesion is equal to 2.9 ton per meter square. Submerged density of soil 0.84 ton per meter cube. So n phi is equal to tan square pi by 4 plus pi by 2. Okay, this formula is also given in IS 6403. So effective surcharge at the base level of the foundation, it is equal to 0.84 ton per meter square. That is given in the problem. So net ultimate bearing capacity in case of general shear failure, that we already discussed in the previous slide, that is QB is equal to CNC SCDCIC plus Q N2 minus 1 S cube D2 by Q plus 0.5 B gamma N gamma S gamma D gamma I gamma and W dash. W dash is the water correction factor. So bearing capacity factor as per 6403 table 1 for phi is equal to 0, NC is equal to 5.1 from table 1, NP is equal to 1 and N gamma is equal to 0. Shaft capacity factors for square footing, that is equal to SC is equal to 1.3, SQ is equal to 1.2 and SM is equal to 0.8. And depth factors is equal to, as we already discussed, this equation 1 plus 0.2 df by b and root under n5. We have already calculated the value of n5. So this is equal to 1.09 and dq is equal to d gamma is equal to 1 for phi less than 10 degree. In this problem, the value of phi is equal to 0 degree. So dq plus d gamma is equal to 1. Okay. Now next is inclination factor. Inclination factor IC is equal to IQ is equal to 1 minus alpha divided by 9 theta whole square. So we know the value of alpha, that is equal to 0. So IC/IQ is equal to 1 and I gamma is equal to 0. Now effect of water table as per clause 6403 5.1.2.4. So as per this clause of I6403, the W dash, the water correction factor is equal to 0.5. Now the net ultimate bearing capacity as per 6403 in case of general shear failure. So QD is equal to CNC. In another video, we have discussed when general shear failure formula will be considered and where the local shear failure will be considered. Okay. So in this case, we will consider the point of view of general shear failure. So QD is equal to CNC SCDCIC plus Q into N2 minus 1 S cube D2 by 2 plus 0.5 B gamma N gamma S gamma D gamma I gamma W dash. By putting all these values, we will get the ultimate general shear failure is equal to 21.06 ton per meter square. Okay. Now considering the factor of safety is equal to 2.5, so the net safe bearing capacity is equal to 21.06 divided by 2.5 is equal to 8.4 ton per meter square. Okay. Thank you. And if you like this video, please share and subscribe. Okay. Thank you once again.